Well, good morning. I'm curious if in the last 24 hours ago, you went to go visit HTTPS 10.18.95.220?
I have no idea.
Really?
Yeah.
It's a very popular site.
I know I've gone to HTTPS sites, but it's just really specific.
Interesting. Well, then let's just move on since you don't have the answer to that question, because today what we're going to be talking about is our F5 BIG-IP DNS product. Now, important to note, this used to be known as GTM, which stood for Global Traffic Manager. Sometimes you'll still see it mentioned in both formats. In today's training, I'm going to specifically refer to it as BIG-IP DNS. And throughout the day, we're going to cover 4 different lessons. I also want to note that I will be talking about 2 different DNS concepts. We've got our standard DNS that's been around for years and years and years and years and years. That's when you'll see it just listed as either DNS or standard DNS. But then I'll also be talking about our F5 product, which is the BIG-IP DNS. Whenever I'm referring to that product, it'll always be displayed as BIG-IP DNS in the materials. So the first thing we're going to talk about this morning, we're going to go through kind of an overview, a reminder, a review, if it's new for you, of just what DNS is in general. That would be standard DNS. And also how different organizations typically deploy DNS out in their environments. Then lesson 2 will focus more on the F5 BIG-IP DNS and what it can do and compare it to what the standard DNS does. And talk about the different DNS services that are available, or the different services that are available with BIG-IP DNS. Now, one of the core things that BIG-IP DNS has always done is global load balancing, or GSLB. So we're going to really talk a lot about that in lessons 3 and 4. And there are a lot of different objects that you're going to be working with when you're setting up GSLB. In lesson 3, we're going to talk about setting up data centers and server objects. And then in lesson 4, we're going to talk about DNS virtual servers. That's different from the LTM virtual servers you've used in the past. We're also going to talk about DNS pools. That's different from the LTM pools that you've created in the past. And then finally, we'll talk about wide IPs. So again, we're going to start out just by talking about why DNS even exists. DNS stands for Domain Name System, been around for years and years and years, and it's for naming. It's helping on the internet with naming as we go out to our resources. So what we're used to when we use our computers is we're used to going to friendly names like Amazon and Twitter and Google. That's how we communicate over the internet. What we're doing is we're contacting web servers, but the web servers, they only know their IP address. Whether their IP address is in IPv4 version or IPv6 version, it's irrelevant. All the web servers know is the address. I asked you earlier if you'd gone to a certain address. You didn't know that address because you're used to those. What DNS does is it takes those friendly names and it turns it into the correct IP address so that we can communicate with those web servers. And that's the purpose of DNS. That's why it's been around for so many years. Let's talk about the process of how this happens. If it's, again, new for you, it's kind of fascinating how this works. So, user, we're going to go to www.f5.com. Again, my computer, in order to communicate with the web server, it needs to know the IP address. So it needs to figure out what that IP address is for that host name. Now, the first thing our computers are going to do is they're going to check the local DNS cache on their workstation, because maybe we already went to this website earlier today. But if we didn't, there's nothing in the cache for that. Then what we're going to do is we're going to contact our local DNS server. Now, our local DNS server is going to be configured within our computer. So, for example, at work, your local DNS server is typically owned by your company. If it's your home computer, your local DNS server is typically owned by your service provider, your internet service provider. So you'll send a request to the LDNS. and say, hey, do you have an entry for this www.f5.com? And again, the local DNS will do the same thing. It'll check to see if it has this name recently resolved already in its cache, because maybe other people that have been using this local DNS have already gone to that website. But if it doesn't, now begins this hierarchical back and forth discussion in order for this server to find that IP address, because there are literally millions of host names that are out there in the world, and there's absolutely no way they could all be contained in one file. So they are spread out on all these different kinds of DNS servers. Now, interesting fact, when you see www.f5.com in DNS language, there's actually a dot at the end of that com. And that dot is what sends the local DNS server to one of the configured root DNS servers out there in the world. There are a few core root DNS servers. And all we're asking for now is to direct us to one of the many .com servers that are out there. So we have a variety of .com servers, we have a variety of .edu servers, we have a variety of .fin servers. And so when you register your domain name for your company, and it's a .com name, it's going to get added to a .com DNS server. So that's all we need to do, is we just need to find a .com server. And that's what that's going to do, is it's going to tell us where to go do that. So now the local DNS can now go to that address, a .com server, and say, hey, do you just have an entry for f5.com? So Amazon.com, Twitter.com, they all should have a host name entry that has been added. Now, typically, all of these companies I just mentioned, they all manage their own DNS server. They're not all, if they've got www.amazon.com and shop.amazon.com and all these different host names for Amazon.com, they're not all just sitting here. The only thing that's listed here is how to get to Amazon.com, or in this case, F5.com. So that's going to send us to the next step, which is the F5.com DNS server. And the F5.com DNS server, that should have all of the host names for this domain, one of which is probably www. If that host name exists, it's going to, the DNS server is going to send the request back, the response back in the form of an A record, which is known as an address record in the DNS world. That address record is now mapped together with the host name and the IP address. The local DNS server is now going to add, and it also has a time to live. The time to live is configured on the DNS server, and that's a way to keep that entry fresh. Because a lot of times web server IP addresses do change dynamically, and we want to make sure we're not pointing people to an old address. So that name will be valid for 24 hours. So the local DNS server is now going to add that to its cache so that any future requests from any other clients, it won't have to go through this process again. And again, it will now use that for the time to live for the next 24 hours. Before it becomes stale. And then it's going to send that, then it will send that host name entry with the IP address to the client that requested it. That client will add it to its cache so that next time it goes to f5.com, it knows the IP address. And now the client can immediately contact via IP address, as it needs to, the web server in question and get the web page. And this entire process takes about a second and a half, everything you just saw, even though it took me 5 minutes to explain it. So that's how DNS works. Now, it sounds very simple in truth, but there are some different ways that we can deploy this. There's some different ways that we can manage it. And that's what we're going to talk about. So first off, let's talk about how we can manage our DNS infrastructure at our company. We have a couple of options. So first off, we have our data center. We have our web servers. We have another data center with web servers. This data center, however, happens to be in a cloud. Where these web servers are is irrelevant. Cloud, private cloud, data center, physical data center is irrelevant. What matters is where is that DNS server and who is actually managing all those names for that company. The www.f5, the internal.f5.com. Who's managing all those entries? One option we have is we can use a third-party provider to do all the DNS management for us. So somebody else is managing the lorax.com domain for our company. Another option is we can manage our own DNS infrastructure. We can have our own DNS servers, and we can manage our DNS infrastructure. Both of these have advantages and drawbacks. When we use this hosted solution, one of the advantages is that we don't really need any administrative staff to do all this DNS management. That's kind of nice. There's a lot less traffic coming into our data centers because none of these DNS name requests have to come to our data center. The only thing that's coming to our data center are requests for our website. Because this is typically managed by a DNS expert, these companies that are DNS providers, that's all they do. They're going to be smarter. They're going to have better reliability. They're going to have fault tolerance. So we can rest assured that our DNS entries are always going to get to us, which also helps keep them safer from DDoS attacks. I like to say that that's their job. That's all they do. And they're going to do everything they can to protect all of their customers' DNS entries. So they typically are going to have a good investment in security products to prevent against DDoS attacks. Now there's some disadvantages. One last thing. This is typically a good option for a small to a medium-sized company that doesn't have as many resources, whether it's CapEx or OpEx, or of course both. Now there are some drawbacks. Reduced control, we don't really have a whole lot of control of our DNS environment. They do. We can make the requests. We can say, hey, I need this entry added. I need this entry changed. But I have to ask for it every single time I need something done. And it's also difficult to really customize our DNS environment or to add to it and extend to it because quite often the way that it's managed is fairly straightforward and regimented, that we have to adhere to their rules. Also, depending upon how many DNS queries we're expecting. So we're going to put out our new public website, and we're hoping we're just going to get thousands and thousands of new users in the first hour. Well, each one of those users is going to have to do a DNS query. So these companies charge based on how many queries per second they're getting. So we have to take that into account, that as our traffic increases, so is our cost in our DNS solution. So maybe it's time to switch over to the in-house solution, because in the in-house solution, we now have all the control. We manage this. That's a good thing. We have full control, which gives us the flexibility of modifying our DNS. We could modify our DNS name if we wanted. We could completely change our old DNS name. We could change subnames. Gives us a lot of flexibility. More often than not, all you really need is the server hardware and operating system. With this on Linux, the actual DNS software is usually very cheap or even free. So it's not a big cost to this. But drawbacks, we now need to have dedicated staff to manage our DNS environment. We now need to make sure that we keep these servers regularly patched so that they're not going to be vulnerable. That's our job now to do that. So those are some of the drawbacks. And what can be really advantageous for a lot of companies is to actually use a little bit of both. So for example, for Lorax, they have their public presence, the lorax.com. So that's where all of their public websites are at, their shop.lorax.com and their www.lorax.com. But they also have loraxnet.com. That's their internal only website, so only employees access that. So what they can do is they manage their DNS environment for just their internal host names, and the DNS provider manages it for all of their public host names. That way they get a best of both. They get the protection and the security and the reliability here, but the flexibility of being able to do what they need on the internal side. Also, what's nice is we have all these internal users here that I don't have on the picture, and they can be using this DNS server as their local DNS server. And so that local DNS server can now send requests it can't resolve, that it doesn't know. It can just send it here. And then this will go out to the root, the .com, and so forth to do all the name resolution for all of our internal users. So that's really nice as well. All right, so benefits. Internal users can seamlessly access all of our external, local and external resources. Easier administration of the user access for all of its internal stuff because we have total control of this. So that's some of the benefits. All right, those are your two different deployment scenarios. Now remember at the beginning of this I was talking about that we have our standard DNS, regular old standard DNS, and then we have our F5 BIG-IP DNS. In order to explain all of the great benefits we have with F5's BIG-IP DNS, it's important to identify some of the limitations that we have when we're using our standard DNS. So in this example, we have and these limitations, by the way, are relevant regardless if we're using the hosted solution or an in-house solution. Same limitations apply. But in this example, we're using a hosted solution for Lorax.com. And we have two different main websites. We have the www website and the shop.lorax.com website. We have two data centers, one in Seattle, one in Richland, Virginia. And you'll notice that the www.lorax.com is located on 4 different web servers. We did that so that we have high availability, fault tolerance. And then the shopping website's on 2 different web servers, 1 in each data center. This has 2 in each data center. So one of the limitations is that standard DNS does not have any care in the world about whether any of these 4 www servers is even available. It does not check for server availability, which means that if a user goes to www and it picks the first IP address as the host to send that IP address to the client, then that client's going to try to go to a server that's not even online. That's a problem, obviously. Also, most DNS servers just use standard round robin of those 4 entries. So I'm going to send the first request here, the second request there, the third request there, the fourth request there, to utilize all of those resources. But what if I'm connecting from Vancouver, BC, and my requests are being routed to Richland, Virginia? That doesn't make a whole lot of sense. That's craziness. Again, standard DNS does not take into account if one server is overloaded or if one server is not available. It just keeps round robining to all of them. Also, standard DNS has no concept of stateful applications. What is a stateful application? You've done some online shopping, I'm guessing, especially right before the holidays. And when you're doing your online shopping, you're building a shopping cart. As you're going to start buying some things, you want to buy one thing at a time, one thing at a time. You want to pool up 8 or 9 items and buy them all together. So what happens is the user, they're going to go to shop.lorax.com. We're going to select one of those servers and we get sent to a Seattle server. And the user begins to build their shopping cart. A shopping application is an example of a stateful application. Stateful meaning I now need to stay on that server because that's where my shopping cart exists. Problem is that user makes another request, but now gets routed to another DNS entry over here, which does not have our shopping cart. Our application is dead. We have other challenges as well. All of the modifications, all of the management up there, it's manual by administrators. And we are the worst people to make mistakes. Layer 8 errors, as we call them. So this user, the administrator realized one of these servers is changing to another server. So they got to change that entry up there from .70 to .40. Click enter. Oh, they got a typo. It's supposed to be, actually it was supposed to be 74. Now we have a totally incorrect DNS entry. That's not good. Also, standard DNS, watch what happens here during a DDoS attack. Any kind of a medium DDoS attack, oh no. Standard DNS is not as well adept at being able to handle massive DDoS attacks. Lots of limitations. And if it's not quite obvious why I would be sharing this, BIG-IP DNS is going to solve all of this for us. But we're going to get to that in just a few minutes. Before we get to that, I'm going to talk about last two things here, which is how we, two different ways that you deploy DNS out there in the world. Again, this is whether you're using standard DNS, BIG-IP DNS. The first is delegation mode. This enables one DNS server to use another DNS server for some of its A records. Not all of them, just some of them. Let me show you how this works. So the user, they've gone to www.lorax.com. We've gone and said, hey, where's the .com? Hey, .com, where's the lorax.com? Oh, okay. Hey, lorax.com, where's www.lorax.com? So in this case, Lorax is doing an in-house DNS. But again, this could be hosted. Doesn't matter. Now, because we're using delegation mode, the lorax.com server actually uses another DNS server for its www DNS entries. And it sends a CNAME, which is known as a canonical name record. It's an alias. It basically says, hey, go over here for what you're looking for. They can help you out. I want to point out that, well, first off, before I get to that, sorry, I'm jumping ahead. In this case, the other DNS server that we're pointing them to happens to be the BIG-IP DNS server, not just a regular DNS server. And the BIG-IP DNS server is being used solely to give out host names for the www application. We do have some other applications on the lorax.com. We have hr.lorax.com, it.lorax.com, and so forth. Those host names are all still being given out by this DNS server. It's only giving out the CNAME alias when people access www. And the benefit here, since we're using BIG-IP DNS, it's now going to come here and say, hey, do you have an entry? We have now, more than one server, just like we did before. We have 2 servers, 4 servers, 5 servers. But BIG-IP DNS can do many things. For example, it can recognize if one of those servers is offline. That's one of many things it can do. So it's never going to give out that host name. It's going to give out that host name, 13.224.51.11, so that the client will ensure going to the correct web server to get their web page. So delegation mode, again, is where this is our regular company's DNS server, and BIG-IP DNS is only being used for some of the DNS work in our company. When you're using this along with BIG-IP DNS, it's important to note you don't get to take advantage of all of the great things we're going to talk about today, all the great DNS services that are available. In order to do that, you would need to use what's known as authoritative screening, also known as inline mode. That will let you use all of the great BIG-IP F5 DNS, BIG-IP DNS services we're going to see. In short, this is going to basically let an organization offload all of their DNS stuff to the BIG-IP DNS. So in this example, we've already gone to .com, .com and so forth, and the .com has now told us where Lorax.com is. So now local DNS is accessing the Lorax.com DNS server. Those are some of the things that we get to take advantage of, which we're going to talk about today. Global server load balancing, iRules, IP geolocation, DNSSEC, which is security related, DNS Express. We're going to talk about all that in a little bit. So now, local DNS is going to contact Lorax's DNS server. And you'll notice that graphic, let me show you that again. Now, this DNS server is not on the side of this DNS server. It's actually in front of this DNS server. And that's the key to inline mode. This is our front level DNS server. We can still use this DNS server. We can still have our entries in here. But this is the DNS server that LDNS is going to immediately contact and say, hey, do you have a record for www.lorax.com? At that point, our BIG-IP DNS needs to send back an IP address for that host. It needs to do a name query response. And it can do that in a variety of ways. There are several different options that we have when we are configuring BIG-IP DNS on how it can answer those queries. For example, we can set up wide IPs, which we're going to talk about later today, lessons 3 and 4 specifically. A wide IP is used predominantly wide IP is used predominantly when we're using global server load balancing, GSLB. That's just one of the features that we have we can use with BIG-IP DNS. It's the one that's been around the longest. But let's say we don't have a wide IP. In this case, we don't. Look, I have no wide IP for www.lorax.com. So it's going to move on to the next thing it'll check. The next thing it's going to check is if we have any configured DNS Express zones. We're going to talk about that in a few more minutes as well. A DNS Express zone lets us offload all of the DNS queries onto BIG-IP DNS for a specific zone. However, we only have one DNS Express zone for loraxnet.com, which means there's no entry in there for that. So the next thing it can do is it can actually send the request to a downstream set of standard DNS servers, if we have that configured. In this case, we do have that configured. So it's now going to go to this DNS server and say, hey, do you have an entry for www? And it says, oh, sure I do. And it sends it back. Then it's going to send it back to the local DNS, and so on and so forth. And then this will now be cached, or could be, I should say maybe. This may be cached on BIG-IP DNS. We'll explain why it would or wouldn't in a few more slides. So those are the different options that we have. We don't have to use all of those. We might only be using one of those options for name query responses. But the key here, in order to utilize all these benefits, the BIG-IP DNS must be in line or in front of our other DNS servers in the organization. So that's lesson 1. That is our kind of overview of standard DNS. We talked a little bit about BIG-IP DNS. We talked about a few of these features, DNS Express we mentioned, and so forth. Now we're going to actually get a little bit more explanation of what some of those other features do for us, what the benefit of BIG-IP DNS services. This is where it gets exciting. So, what can we do with the BIG-IP DNS? We've already talked about global server load balancing, GSLB. The concept of GSLB is to let us do a couple of things. One is we can utilize multiple data centers, and BIG-IP DNS can route requests across multiple data centers. We like to offer full availability. It's one of the things we're known for at F5. We make applications available. But if all we have is our Seattle data center, I could have the biggest and best BIG-IP in there. I could have 2 BIG-IPs for fault tolerance and have a nice pool of web servers But what if that whole data center goes down? There goes our full availability. There goes our 5 nines. The only way we can achieve 5 nines is to have multiple data centers, and that's what GSLB will do for us. What's nice about using BIG-IP DNS with the GSLB is we can utilize our IP geolocation so that, remember earlier, we talked about how silly it would be for me connecting from Vancouver to be sent to the Richland, Virginia data center. That's what standard DNS can do. With BIG-IP DNS, we have IP geolocation, so we can recognize that this request is coming from Australia. And it would make no sense to send that request to one of these two when we have a Singapore data center. So it's always going to send that to the nearest data center based on the incoming client. And, of course, we can identify when an entire data center goes offline and then send it to the next smartest available data center. That's our global server load balancing. DNSSEC, DNS security is what security extensions is what that stands for. What we want to make sure that we do, remember that we're going to be getting information from other DNS servers. We're going to be getting results from other DNS servers, and it's very possible with hackers, with malicious users, that they can put incorrect entries into our DNS server so that we're now pointing users to the wrong places, malicious places. It's known as DNS cache poisoning. They're trying to get malicious entries into our DNS cache. So DNSSEC is a feature that was enabled a while back, years ago, to help DNS servers prevent that. We have that available on BIG-IP DNS. We also have DNS Express. I have a whole slide on this and a few more slides here. But in short, this enables BIG-IP DNS to completely take over the job of our other DNS server completely, or at least for one zone. We also have a lot of security built in to BIG-IP DNS. It can act as our security. We have a lot of security built into it. And then we also have our DNS 6.4, also known as DNS 6.4. This is going to be very helpful for us when we have the challenge of some of our entries that are coming in to do name resolution queries that are IPv6 clients. But all of our host names, all of our web servers are still using IPv4. An IPv6 client has to speak with an IPv6 server. So we can do the translation so that we can make sure that we send out the appropriate name query result to different IP versions. And we can do all of that on BIG-IP DNS. In addition, if you are familiar with our F5I rules, we like to say that you can pretty much do anything with an I rule, except maybe wash your dishes at night. And so anything that's DNS related that may not exist in our configuration utility right now, you can probably find a way to do it because we have the DNSI rules. So those are some of the things that are available with DNS, BIG-IP DNS, excuse me. Now we talked a little bit about attacks and security and that BIG-IP DNS helps to protect. One of the main things it's protecting against is BIG-IP DDoS attacks. Very, very popular, second most popular attack type out there right now. Why? I'll give you a quick example. This happened a few years ago. If I'm a hacker, I can just target the Facebook.com website and target that, and do everything I can to take down that Facebook website for an hour or two, and that will give me a lot of satisfaction. But what happened a couple years ago is we saw a lot of web servers, web applications not available. Facebook, Amazon, Twitter, they all became available because if I can take down the DNS system and we have no hostname resolution, no matter where the user is connecting from, when they go to Facebook.com, if they can't get an IP address, they're not going to connect to their web server. So taking down the DNS system has a more dramatic effect than just taking down individual web servers here and there. So it's a very popular attack type. And we have lots of built-in features with DNS to protect against DDoS attacks. And we also can combine it with our Advanced Firewall Manager, AFM, which also has a bunch of additional attack vector types that are DNS DDoS specific. Put the two together, you've got some amazing DNS protection that you're really not going to find on any standard DNS server. So these are some of the things you'll see. Flooding requests to a given host, just trying to flood it with names, trying to do the cache poison, we talked about that, where I'm trying to put bad entries into a DNS server's cache, so that other users that access that same host name are going to get pointed to the wrong place and so forth. So those are some of the attack types that we're going to see with DNS DDoS attacks. So we talked a little bit ago about DNS Express. This I think, is one of the most impressive features we have with BIG-IP DNS. So right now, we have all of our management of all of our host names on this local DNS server. It's an old Unix box, it's slowing down. We got this BIG-IP DNS. Fast, amazing. So what we're going to do is we're going to make this the authoritative DNS server for all of our host names. That used to be done down here. What we do is we use what's called a zone transfer. A zone transfer will take an entire zone, like Lorax.com or Loraxinternal.com or whatever. It'll take that entire zone. So here we have two different zones that we're managing. We can take an entire one of those zones, move the entire contents of that to the BIG-IP. It goes in RAM. Anything that's in RAM is going to be faster. And now, and notice, by the way, we can select, we can choose. We've chosen not to do a zone transfer for this zone. We could, but we've chosen not to. And now, when the local DNS server says, hey, do you have an entry for that? It can answer every single entry for Lorax.com without having to come here and talk to this DNS server. It becomes the answerer for all of our queries. And not only is that nice, but it's actually fantastic because it can handle tens of millions of DNS records and, more importantly, millions of DNS queries per second, which you're going to have a hard time finding on this old Unix box that we have here. So it's going to be a much faster DNS solution for us. And all we had to do was a zone transfer that can take seconds to move all that information over here. That also is going to help us with DDoS attacks because now we are not relying on this vulnerable DNS server at all. Everything is going to be now happening here. The buck stops here on the BIG-IP. Nothing comes inside anymore, which is nice. So for example, if somebody's trying to mess with our DNS system and do some cache poisoning to this poor DNS server that doesn't have a lot of security built into it, and they send this request and gets to the BIG-IP DNS and says, hey, do you have a record for xxx.lorax.com? BIG-IP DNS says, do I? No, I don't. So it's not configured to go do any other querying. It's not going to go ask this server. It just simply says, sorry, no entry. And so we do not bother the backend web server with any of those bogus requests. So that's the benefit of DNS Express. Now, if we've chosen not to use DNS Express, you have an alternative. We can just do standard caching using DNS caching. This does have huge drawback and limitation. I'll explain why. But essentially, just like a local DNS or our client. If it has the name in the cache, it'll give that name. If it doesn't have the name in the cache, it has to go ask somebody else. So this request comes in. Hey, do you have a request for www.lars.com? It's going to look in its cache. Hey, there's nothing there. So it's now going to go to a configured server, a configured pool of DNS servers. It'll get the answer, send the answer to the local DNS server. Oh, I'm sorry. But now, anytime another request comes in, as long as this time to live hasn't expired, now it can go ahead and answer it from the cache, just like a local DNS server would. That sounds good. But the problem is, when we're only using caching, the BIG-IP DNS is really only going to have a few entries in its cache for the names that have been requested a lot. It's never going to have the whole zone in its cache. That's one drawback. But another drawback is this. Hey, do you have an entry for XXX? Nope, let me go check here. Now we're sending those bogus requests to the downstream server. So caching makes these DNS servers more vulnerable to DDoS attacks, because what's going to happen? You have ABC? No. You have DEF? No. What about GHI? It's just going to keep sending those through because it's not in its cache, and eventually the DNS server can still go offline. So because of that, you will notice in a few more slides that we actually disable DNS caching by default. And we force you to enable it if you actually really want to use it. So we talked about a variety of different ways that BIG-IP DNS can answer these name queries, answer these requests. If we're using all of them, let's say, you could use all of them. There is an order of precedence that BIG-IP DNS takes to find the right answer to give you for your request. So let's take a look at this. The first thing that's important to note is, in order to set this up, we have to have what's called a DNS Listener. The DNS Listener, this is the DNS server that the .com server is sending us to when we go to lorax.com. That's our DNS server address, essentially. So we're going to send this request to the DNS Listener. It's now going to check to see if it has an answer for us. And the first thing it's going to check is a wide IP. We talked briefly about that earlier. We'll talk more about that later. But as a reminder, wide IP is used for global server load balancing. The next thing is to check. If it didn't match a name as a wide IP, the next thing it's going to check is if there's a DNS Express zone that matches that entry, that name entry. If there's not, then it's going to check its cache, if that's been enabled. Maybe it hasn't been enabled. If that doesn't match, then we will see if there's a configured pool. This is not a DNS pool, by the way. That should actually say LTM pool, but it's a LTM pool of DNS servers. So those are those DNS servers that we can forward requests to if we don't have the answer. We might have that configured. We might not. If there's no matching entry there, then we have what's called a cache resolver that we can set up. That's a BIG-IP feature. And then finally, if there's no matching request there, the last thing we can have configured, if we choose to, is the BIG-IP itself has its own configured DNS setting, its own DNS server that it's configured to use. We could use that DNS server as a final option. All of these, for every listener, all of these are either going to be enabled or disabled features. We get to choose. And where we enable them or disable them is in one of two places. One of the places they might be enabled is when we actually configure the listener itself. So we have our DNS menu. That's where we're going to do all of this stuff that we're going to do in the next several hours, all the lessons we're going to cover. Everything's under the DNS menu. Under Delivery Listener, this is where you can create a new listener. And again, just to iterate, a listener is going to be a DNS server that's accepting DNS requests and trying to give an answer to somebody. So I have a listener, I'm just giving it a very generic name here, but this is, again, the IP address that the .com server is going to send requests to for their next hop. If I take this to advanced, you'll notice it shows you the port. We always use 53 as our DNS port. I don't know why you would change that. I don't think you should or would. I also like to point out, this is just a kind of an FYI thing, that once I create this listener, once this listener is created, if I were to go to my LTM virtual servers, you'll notice that it actually has created a virtual server here as well. It's one and the same. The same object, it just displays it here as well. There's the IP address, there's the port. That's just an FYI thing. But I told you that all of these are going to be either enabled or disabled in one of two places. So a couple of them are enabled inside of the listener, such as a pool. If I'm going to use a pool that I'm going to send requests to, I would add it here. This pool you would set up under the LTM pools menu, and it would just be a pool of one or more DNS servers. But we don't have to have it. That could be set to none. The rest of all of these entries, that one, those are all going to either be enabled or disabled in a DNS profile. So I will create a DNS profile that has all those settings and then specify that DNS profile in the listener. So once I save this up, now let's go take a look at the profile, the DNS profile. And each listener can have its own custom DNS profile, of course. So now I've got my profile. I'm on my delivery profiles page. I've got this profile called custom DNS profile. We just looked at that. So first thing, GSLB. Remember that wide IPs are used for GSLB. So this is how we either enable or disable the use of wide IPs for that listener. Now that doesn't mean there's going to be a wide IP that matches. It just means I can use wide IPs. I still have to go create a wide IP that matches. You'll do that later on in your exercise. We also have DNS Express. That's also going to either be enabled for this listener or disabled. By default, we have it enabled. But again, that doesn't do anything until we actually have a DNS Express zone that we've transferred over. But this just enables us to do that, to use that. Caching, DNS caching. I told you that this is disabled by default. We recommend that. Why? Again, because caching can make us more vulnerable to DDoS attacks. So we typically keep that disabled. And then also, if you're using a cache, what's called a cache resolver, you would go create that in another spot on the BIG-IP and then select it here. We're not going to get into that very much. It's not used very often. And then finally, a little bit further down, you will see the use bind server on BIG-IP option. Again, it's either enabled or disabled. And if it's enabled, that enables us to use the BIG-IP's configured DNS setting. So that's how we set up this order of precedence and which of these we could potentially use to answer queries. Once you've got this set up, once I've got my listener, it's important to do some testing to ensure that we're getting proper name resolution. So let's say I have a wide IP configured, I have a DNS Express zone, and I have a back-end pool of DNS servers, all of them configured for my listener. What I want to be able to do is I want to be able to do a name resolution, and I want to verify, well, which of those entries actually answered the query. Was it the wide IP that answered it? Was it the DNS Express zone that answered it? Or was it the back-end pool member that answered it? So we can get some information by a couple of tools. One is the dig command. That is a standard, long-used DNS tool. When you use the dig command, You're going to specify whichever DNS server you want to go ask. That's our listener. That's our DNS listener we created. And then just put in a host name, one of the host names. And then you're going to look and see what the response is. This is the response that we got from somewhere. The wide IP, the DNS Express zone. Now we have a lot of tools within, tools and statistics and all that built into the configuration utility, so you can actually see exactly what answered that query for us. Now the dig command is a one-time command. I run this command, I get an answer. I could run the command again, I could get another answer, and keep on going. We have another DNS tool that's used quite often called DNS Lookup. DNS Lookup, name server lookup, DNS Lookup. This is slightly different from dig in that when I go to DNS Lookup, I actually kind of go into a DNS Lookup mode. I'm now inside of a DNS Lookup mode here, and I stay inside that mode for as long as I want to. And I can just look up multiple host names over and over again. I put in the server. That again is the DNS server address. I put in a host name, and then I can look at the results. This is the result that was sent back. We got that result from somewhere. Could have been the wide IP, could have been the DNS Express zone, who knows? And then finally, if you're using a DNS Express zone, if you're using that, it's important to find out, once you've done this zone transfer, which is actually very easy to do, you're going to do it in your next exercise. The zone transfer, again, is going to take all that information from the standard DNS server and it's going to transfer it over to BIG-IP DNS. Once I've done that, I want to know if it was successful. I want to know if it's going to work. So we have two ways we can identify that. The first is we can just look at our standard LTM log. And what we're looking for is we're looking for an entry here that says, hey, look, the transfer of the zone, f5demo.com, succeeded. So we know, hey, zone transfer actually took place. That's good. In addition, we can use this command, dnsx-dump. What that's going to show us as we scroll down here is it's going to show us every single name entry and IP address that was received during the zone transfer. These are all now host names that the BIG-IP DNS can answer as a result of this zone transfer. Any questions? So that will all stuff you're going to play with in your first exercise. So in this exercise, you already have DNS provisioned on your in your environment. So you're going to go in and you're going to create a profile, a DNS profile. And it's important to note, you're actually not going to change any of the settings. You're going to use all the default settings for the DNS profile. Then you're going to create a DNS listener and a DNS pool. So the DNS pool is going to be our back-end LAMP server that we use that has, our DNS records. And then you're going to test some name resolution just using the DNS pool, the pool of DNS servers. But then you're going to do the DNS Express and test that out. And when you test that out, the idea is to see, at that point, we now have two different methods of answering names, the pool and the Express zone. So now when I test name resolution, I want to see, hey, which of those two actually answered the query? And then you're going to add a very simple wide IP address, a wide IP. Now when you test, now you've got three different ways to answer the name. And you want to verify, hey, did that name get answered by the wide IP, by the DNS Express zone, or the pool? And that's what I want you to see in this exercise, which will take about 40 minutes to complete. And we'll see when we're done with the exercise.